Okay, I wanted to talk about chapter 4 because I want the majority of this chapter to be included on the first exam. So I'm going to talk briefly about the amino acid structure and the properties of amino acids and some characteristics that I would like for you to remember. Amino acids are nitrogen-containing organic molecules. Of course, you know they are the building blocks of proteins. There are 20 standard amino acids, and these 20 standard amino acids consist of 10 that are essential. That is, we don't have the enzymes to make these amino acids, and we have 10 that are non-essential. For the most part, we are capable of synthesizing them. So I'll hopefully mention those that are essential, those that are non-essential, as well as the single letter and the triple letter code for each amino acid. The amino acids represented in Table 4 are given in their ionic form at a pH of 7.0. If you'll notice that amino acids have a structure where the alpha amine group has a positive charge and the alpha carboxyl group has a negative charge, and these two charges are present at around pH of 7. The amino acids are grouped according to their specific characteristics regarding their charges and solubility, and these three major groups include nonpolar, charged, and uncharged. And what we're referring to is the R group, or the side chain as it's sometimes referred to, not the amine and the carboxyl ends of the peptide backbone, but the side chains. And so these characteristics all refer to the R group in each of these amino acids. The nonpolar amino acids include alanine, valine. Alanine, of course, the symbol single letter A, valine, single letter code is V. Leucine, L, and isoleucine, I. Glycine is also considered in this category, although it's not absolutely nonpolar, but it has the smallest side chain in that it's hydrogen, only hydrogen. So these aliphatic hydrocarbon side chains are nonpolar. Additionally, we have methionine, which has a thiol ether side chain. Phenylalanine contains a phenol moiety or phenol group. Tryptophan, one of the largest side chains of the amino acid, has an indole group, and proline has what's referred to as a cyclic pyrrolidine. It is the only amino acid that contains a secondary amine group, because the structure, you can see, the side chain is bound to that N-terminus as well as to the carbon, the chiral carbon or the central carbon. So of these 9 non-polar amino acids, the essential ones are methionine and phenylalanine and isoleucine, leucine, tryptophan, and valine. There are approximately 6 uncharged amino acids. These 6 amino acids are considered uncharged at pH 7.4, which is physiological pH. But if you were to raise or lower that pH, and depending on the pH at which the hydrogen dissociates, the side chains would become charged and polar. These include serine and threonine. They're hydroxyl side chains. Asparagine and glutamine, which contain amide bonds or amide functional groups. Tyrosine, which is the hydroxylated form of phenylalanine, and cysteine. Cysteine is particularly unique because it contains a thiol group that's capable of being oxidized and form a dimer or a disulfide bond with another cysteine residue. And this dimeric compound is often used to in the quaternary structure of proteins. Of these 6 uncharged yet polar amino acids, we have asparagine is a non-essential amino acid. Glutamine is also a non-essential. Tyrosine is non-essential. Cysteine is non-essential. And I don't know if I mentioned, but among the non-polar charged amino acids, the non-essential amino acids are what were left: alanine and glycine and proline were the only amino acids in that group of uncharged yet polar amino acids that are non-essential. And what is left are the charged amino acids. These are charged. There are 5 of them. These are charged at a pH of 7.4. Lysine. Lysine contains what's referred to as a butyl ammonium side chain. Arginine bears a guanidino group. And histidine carries a imidazolium group. And histidine is the only amino acid that can be charged or uncharged at physiological pH 7.4. Additionally, the lysine and arginine and histidine are essential amino acids. Aspartic acid and glutamic acid are non-essential amino acids, and they contain carboxylic acid in their side chain. When these carboxyl groups are deprotonated, they form the conjugate base of aspartic acid, and they're referred to as aspartate and glutamate, and they have these unique 3-letter and single-letter codes. A couple of other properties I wanted to mention about these amino acids. For one, they all contain chiral center. The alpha carbon, or the carbon between the carboxyl group and the amine group, is chiral. As a result, a chiral center allows for enantiomers, or mirror images, to form. This alpha carbon is described as the chiral center, and in amino acids, in humans at least, the configuration around this chiral center is levorotary. That is, a pure solution of an amino acid would rotate, with a couple of exceptions, would rotate plane polarized light to the left. As a result, this configuration is levorotary, and so all amino acids are in the L configuration. All is naturally occurring. They're alpha, and that is the stereochemistry configuration of all amino acids in humans. When amino acids condense, we talked about the condensation of amino acids. The side chains are not typically involved. Condensation of amino acids occur between the alpha amine group and the alpha carboxylic acid group. Water is produced after the condensation, plus you form a bond between the amine and the carboxyl group that's referred to as an amide bond, peptide bond, And this bond will also later on be referred to as the scissile bond, because this is the bond that is targeted by specific proteins that hydrolyze polypeptide chains. So polypeptides, dipeptides, tripeptides are formed by this type of condensation between the alpha amino group and the alpha carboxyl group. Okay, that pretty much covers chapter 4, but we'll pick up there after the first exam.